2000s and 2010s gave us new innovations in cluster computing and mobile computing. These were distributed. Some of them used touch screens, and they had to pay attention to how much energy they were consuming. This is an example of a cluster in a Google data center. On these large clusters, many hundreds of cores share work. In order to share work, it requires that they have some homogeny of environment, which gave rise to the need for distributed operating systems. Mobile computing, on the other hand, may only have had one device at a time, but that device had to be able to interact with the user through the touchscreen and monitor its energy usage. So if we compare the phone that you might have in your hand right now to the machine that we started with back 70 years ago, the price has come down, the speed has gone up, the energy that the phone uses is less than the amount of energy utilized in your brain, and the weight is significantly reduced. So lastly, we come to an image of the layer cake model for data movement in a modern processor. This is shown with the Intel i5-7200U processor, which has 2 cores. Those 2 cores are CPU 0 and CPU 1. Each of those cores has its own level 1 cache, which contains data separately from instructions. We also have each of them controlling their own level 2 cache, and then they have a shared last level cache. Now, underneath that, they also have memory, which is random access memory, and secondary storage, both of which depend on the underlying architecture of the computer that was built. But as an example, as that size increases in the amount of data that a certain layer of storage can hold, the latency it takes to reach that also increases. So the level 1 cache is always 32 kilobytes for data and 32 kilobytes for instructions, which as a whole is 64 kilobytes per core. The level 2 cache can vary, but in this particular case, it's 256 kilobytes per core. Last level cache, which is shared between all cores on the processor, in this case is 3 megabytes. And then if we go down to memory, we have 8 gigabytes. Now, chief of interest here, we can use networked memory, which may be faster than accessing the secondary storage on our device. And we can use networked secondary storage, which gives us access to more data than we can possibly hold on our single computer. So if we look at latency, it takes roughly on the order of nanoseconds to access information from cache. It takes microseconds to access memory using remote direct memory access from other memory units that are not on our computer. And it takes on the order of milliseconds to access secondary storage, regardless of whether that's on our computer or on somebody else's computer. As the size increases, so does the amount of time that it takes to access information from that storage layer. So finally, when we're discussing operating systems in particular, we care about only the layers that the operating system controls. The operating system schedules programs to run on cores on the CPU. The operating system manages memory, and the operating system handles access to secondary storage.